Next session, leading healthcare and health tech organizations use AWS to streamline innovation. To deliver patient-centered care, healthcare providers need to increase the pace of innovation while keeping health information secure. AWS empowers healthcare organizations to make the most of their data with a host of cloud services. We have with us Leon Jackson, Healthcare Chief Technologist, Asia Pacific and Japan of Amazon Web Services. Welcome, Leon.
Hello, my name is Leon Jackson, and I'm here to talk to you today on how customers of AWS are using the cloud to streamline innovation in healthcare and life sciences. AWS Healthcare and Life Science mission is to enable access and delivery of person-centered healthcare, driving improved outcomes at a lower cost by accelerating the digitization and utilization of healthcare and life sciences data. We do this by providing the highest levels of security, compliance, and data privacy. We help customers build data platforms to gain actionable insights from valuable health data. You can't predict the future, but you can put in place the infrastructure and tools required to adjust to changes as quickly as possible. Data helps you identify changes, and the right data and analytics approach helps you make the right decisions quickly as changes occur. Two great examples are when demand for ventilators soared during COVID-19 pandemic, the medical device manufacturer Ware Medical found itself handling manufacturing volumes it never would have imagined just weeks before. Order volumes suddenly increased by a factor of 20 times. The ability to scale was possible because Ware's newly modernized analytics solution built on Amazon S3 and Amazon Redshift as their data warehouse. Moderna is well known for its COVID-19 messenger RNA or mRNA vaccine. It was founded in 2010 with the goal of delivering on the promise of science to create novel medicines for unmet patient needs. They invented proprietary technologies and methods that run on AWS to create mRNA constructs that cells recognize as if they were produced in the body. This invention has empowered Moderna to experiment rapidly on virtually any mRNA sequence, easily shifting between research priorities without investing in new technology. Moderna runs its drug design studio on AWS highly scalable compute and storage infrastructure to quickly design mRNA sequences for protein targets. It uses analytics and machine learning to optimize those sequences for production so that the company's automated manufacturing platform can successfully convert them into physical mRNA for testing. Let's frame the data challenge. Let's talk about the value of data and analytics in health from the benchtop or the labs of research, genomics and other life science institutions to the bedside, which is to say the front lines of where care is being provided. What many customers have told us is they face challenges to get insights from research to become more actionable at the point of care. Precision medicine is one example where these insights are translated to an individual patient for more precise drugs and therapies. And on the reverse, is to get the actual clinical data or evidence back to researchers. We have helped customers build modern research benchtops with multimodal data from clinical evidence and diagnostics to genomics and medical device data with the use of AI ML services such as Amazon SageMaker. So the usual goal for the flow of benchtop to bedside is usually for precision medicine or clinical decision support. And the goal for the flow of data from bedside to benchtop is to equip researchers with valuable data and evidence. And customers usually look for tools to ensure quality of data and analysis and to ensure that patient privacy is protected. For example, data used for research may be de-identified or anonymized to compliance standards such as HIPAA or GDPR. Let's talk about overcoming data silos at the bedside with interoperability and infrastructure. Let me explain what I mean by Health Infostructure. In 2020, publication from WHO and ITU called Digital Health Platform Handbook, Building a Digital Health Information Infrastructure or Infrastructure for Health. They explain the problem like this. Siloed digital health systems have emerged because most digital health implementation projects occur independently. A digital health platform is a common digital health information infrastructure or infrastructure on which digital health applications are built to support consistent and efficient delivery of healthcare. The infrastructure comprises an integrated set of common and reusable components that support a diverse set of digital health applications. By supporting interoperability, the underlying infrastructure ties different components and external applications together into a streamlined and cohesive whole. How does AWS help with building infrastructure? The extensive collection of services from compute, networking, storage, data transformation, analytics, AI, ML, and AWS on a pay-as-you-go consumption model make it easier for customers to string together an infrastructure available from any secure connection. Customers want more value from their data. Data volumes are increasing at an unprecedented rate, exploding from terabytes to petabytes and sometimes even exabytes of data. Traditional on-premise analytics approaches can't handle these volumes because they don't scale well enough and are too expensive. Customers are looking for highly scalable, available, secure, and flexible data storage or a data lake that can handle extremely large data sets. With a data lake, customers can store all their structured and unstructured data using open data formats of their choice, like ORC or Parquet, and tag their data in a central searchable catalog. They need to be able to run multiple analytics services against their data in order to ensure that they have the right tool for the right job. They need to be able to move data between the data lake and the services in all directions, from inside out to outside in and around the outside. They need to have a unified governance across data and services to simplify securing, managing, and monitoring access to data. And of course, they need services that give them low cost without compromising on performance or scale. We call the modern data architecture for analytics modern data architecture, and this helps underpin a health infrastructure. Let's talk about modern data architectures on AWS. It starts with Amazon S3. Customers have been building data lakes on S3 longer than any cloud provider, and today, more data lakes run on AWS than anywhere else, using Athena, an interactive query service to analyze all their data. In addition to data lake, customers use a combination of purpose-built databases and analytics services like EMR, Amazon OpenSearch Service, successor to Amazon Elasticsearch Service, and Redshift to ensure that they are using the right tool for the job to get high performance and scale at the lowest possible cost. To move data between these systems, they use AWS Glue, our serverless data integration service. And finally, they use lake formation to manage the security and governance of all their data, regardless of wherever it sits, in the data lake or in purpose-built stores. And in all these cases, we've invested heavily in offering the best price performance out there. We call this modern cloud-based analytics architecture, the modern data architecture. And customers have used this modern data architecture to build their health infrastructure. The other aspect to infrastructure would be FHIR interoperability, which I will get to in a few slides. Customers are building their health infrastructure on AWS for some of the following initiatives: clinical information systems, AI and machine learning for analytics and clinical decision support, improving the patient and clinician experience with omni-channel communications and AI ML-powered personalization, medical research by giving researchers access to tools and data, finance and operations, and modernizing their core IT as they migrate data and applications to the cloud. Let's talk about tools that customers would use to build a trusted research environment, or a controlled environment that gives researchers access to data and tools without letting them take that data away. Some of the purpose-built services to help managing and analyzing data are like Athena, which is an interactive query service that makes it easy to analyze data directly in S3 using standard SQL. With Athena, there's no need for complex ETL to prepare your data for analysis, and most results are delivered within seconds. This makes it easy for anyone with SQL skills to quickly analyze large-scale data sets in S3. If you want to quickly search and analyze large volumes of log data to monitor health of your production systems or troubleshoot performance, or even search your fire resources on the AWS Fire solutions, which I will talk about later, you can use OpenSearch. If you want to do real-time processing of streaming data, you can use Amazon Kinesis. We have complex queries against structured data, and you want super fast query results, you may want a data warehouse like Amazon Redshift. These are services built to be best of breed, which means you never have to compromise on performance, scale, or cost when using them. For example, Amazon Redshift is 3 times faster and at least 50 times less expensive than other cloud data warehouses. Spark on EMR runs 1.7 times faster than standard Apache Spark 3.0, and you can run petabyte scale analysis at least half the cost of traditional on-premise solutions. Our services and features include ETL, visual data prep, data replication, movement to and from your data lake to the data warehouse, and federated querying. Let's talk about AWS Glue. AWS Glue is a serverless data integration service that makes it easy to prepare data for analytics, machine learning, and application development. AWS Glue provides all these capabilities needed for data integration so you can gain insights and put your data to use in minutes instead of months. Traditional data integration is a complex and iterative process that involves multiple tasks, such as extracting data from various sources, enriching, cleansing, normalizing, and combining data, and loading and organizing data into databases, data warehouses, and data lakes. These tasks are often handled by different users and use different products. AWS Glue provides both visual and code-based interfaces to make data integration easy. Users can easily find and access their data via AWS Glue Data Catalog. Data engineers and ETL, extract, load, and transform. Developers can easily create, run, monitor ETL workflows with few clicks in AWS Glue Studio. Data analysts and data scientists can use Glue DataBrew to visually enrich, clean, and normalize data without writing code. AWS Glue Studio is a new visual interface for AWS Glue that makes it easy to ETL for ETL developers to author, run, and monitor AWS ETL jobs. You can now use a simple visual interface to compose jobs that move and transform and run data and run them on AWS Glue. You can then use AWS Glue Studio job run dashboard to monitor ETL execution and ensure that your jobs are operating as intended. AWS Glue DataBrew makes it easy for data scientists and data analysts to clean and normalize data using a visual interface. You're reducing the time it takes to prepare data up to 80%. With Data Glue, you can visualize, clean, and normalize data directly from your data lake, data warehouse, and databases. And now in preview, Glue Elastic Views. Glue Elastic Views lets you use SQL or SQL to quickly create a virtual table called Materialized View of the data that you want to combine in different sources. Based on the Materialized View definition, Elastic Views copies data from source database and target database, and automatically keeps the data in the target database up to date. How about moving data to and fro the data lake? Amazon Redshift Spectrum enables you to run Amazon Redshift SQL queries against exabytes of data in Amazon S3. With Redshift Spectrum, you can extend the analytics power of Amazon Redshift beyond the data stored in local disk of your data warehouse to query vast amounts of unstructured data in your Amazon S3 data lake without having to load or transform any data. Another capability to enable fast sharing between your data warehouse and data lake is Amazon Redshift Data Lake Export. You can unload the results of a Redshift query onto your S3 data lakes as Apache Parquet, an efficient open columnar storage format for analytics. Another part of data movement is being able to query across all data sources, databases, data lakes, and data warehouses. Athena enables you to run SQL queries across data stored in relational, non-relational, object, and custom data sources. You can use familiar SQL or SQL conjoins and join data across multiple data sources for quick analysis and store the results in Amazon S3 for subsequent use. With federated query capability in Redshift, you can query live data for one or more Amazon RDS